Okay, good morning class. So you guys had homework. The homework was exercise 2.7 on page 31. Not so. You had to do number 1, 2 and 3. Is that correct? Just number 1. Any issues there? Sorry? Yes? Sorry? C. Okay. Which page is this on? 31. Page 31 from the Keeping Math Simple textbook, okay? Clever Keeping Math Simple. Okay. So it says show that all the rectangles have the same perimeter. That wasn't the issue. Then it says calculate the area of each of the rectangles. That shouldn't be the issue. What you should have noted there is that even though the perimeter is the same, the areas differ for each and every one there. Not so. Which means to say there will come a point where dimension with this perimeter of 200, no? With this perimeter of 200, there will come a point where you will have the maximum area that will occur for this given triangle. Okay. C says a rectangle has a fixed perimeter of 200 meters. Let the width of the rectangle be x. Determine y in terms of x. Okay. So a rectangle, they want the width to be x. They want you to write the length in terms of x. But how do you calculate the perimeter of a rectangle? 2 length plus 2 breadth, not so. So I say my breadth is basically my width, so it's 2 length plus 2 and my width is x. And what is the perimeter of this piece? 200. So if I'm going to make L the subject of the formula, I take 2x over, so it's 2L is equal to 200 minus 2x. Now I divide by 2. So your length is going to be 200 divided by 2 is 100 minus. Can you see that? Your length in terms of x. 100 minus x. Then the question, this is number 1. Let's go with number 2. Show that the area can be given as that. People, how do you calculate the area of a rectangle? Area is equal to length times breadth or length times width. Okay. And what's my length? 100 minus x. And the breadth, x. So that's going to be negative x squared plus 100x. Now without reading the next value, looking at negative x squared, with this, does this area model a maximum or a minimum turning point on that parabola? Maximum. Why? So the coefficient of x squared is negative. Now when that is negative, then the examiner would always ask for maximum. You understand? If this had to be positive, then the examiner would ask a minimum question. It's the same calculations that goes into play, not so. But if it's a maximum model, they'll ask you maximum. If it's a minimum, they'll ask you minimum. You understand? That's how it is. So number 3 says, find the dimensions of the rectangle that has the largest area. What is largest area? Maximum. Okay? And determine the maximum possible area of this rectangle with a perimeter of 200. So that would simply be, you need to complete the square. Okay, so you say A equals. Let's complete. So we're going to complete the square. There's negative x squared plus 100x. So what do we do first in pursuit of completing the square? Negative out the common factor, yes, and then x squared minus 100x. Okay? You all agree with that? So that is just behind. Move this over. Okay, so the question is, what must we must add a number to complete the square with, and you must minus that same number. What's the number in this case? What is 100 times half? Huh? 50. And 50 squared is 2,500. So what do you notice here? You have a perfect square trinomial. Not so. So that's going to give you x minus 50 squared minus 2,500. So what do I do now? Multiply. Get rid of the brackets. So that's simply going to give us negative into x minus 50 squared plus 2,500. But did we answer the question? No. What's the question? The question I want to know. Find the dimensions of the rectangle that has the largest area and determine the possible area. Okay, so the largest area is going to be, therefore maximum area is going to be 2,500. This is in meters, so meters squared. So what's my dimensions? Dimension is the width. And what's the width of this? It's just x. And the maximum occurs at what? X is equal to 50. And the length, which is this here, it's 100 minus 50. What's 100 minus 50? Also 50. So the largest possible area will occur at the width of 50 and the length of 50. And 50 and times 50 is 2,500 anyway. You guys understand? So that's that. Any other confusion regarding this question? Then we went on, okay, before we carry on, your homework from exercise 2.7 is number 2 and 3. That's on page 31. Okay. Then we went into quadratic equations, not so? You had to do the odd numbers here of exercise 2.8, not so? Then the last few examples that was on the board I explained in the video. So if you had a problem, you just had to go watch the video and you would have gotten the 3 questions. Was there any issues with 2.8? You had to do the odd numbers. Yes? Number 15. Any other problems? Exercise 2.8, number 15. Anything else? Which page is this on? Sorry? 34. So only number 15 is the issue. Okay. For homework, I want you guys to do the even numbers. Okay. Okay, so number 15, this deals with a trinomial. No? It's quadratics, so it's trinomial. So we need to draw the product line here, not so. So which factors goes on the line? 1 and 4, 2 and 2. Factors are 3, 1 and 3. Do I add or subtract my products? You subtract. So 1 times 3 is 3, 1 times 4 is 4, 3 minus 4 is 1. I'm looking for 4. Okay? 2 times 3 is 6. 2 times 1 is 2. 6 minus 2 is 4. And that's what I'm looking for. So in the bracket goes a 2 and a 1. And a 2 and a 3. Not so? What about our signs? 1 plus, 1 minus. Sign must be different. Why must it be different? Because that is negative. Okay? So 2x times 3 is what? 6x. 2x times x is 2x. So this must be positive, as that is positive, and that will be negative. But never do we put the sign in front there. No? So we'll put the sign there, positive and negative. Right? So the question was to solve for x. So what do we do now? We say 2x minus 1 is equal to 0, or 2x plus 3 is equal to 0. So 2x is equal to 1, x is equal to half, 2x is equal to negative 3, x is equal to negative 3 over 2. Okay. So what was the issue? We took out 4 as a common factor, but then you're going to get a fraction in the last term. Yeah, I think you want to complete the square again. No? This is not completing the square. You could have actually completed the square or gotten the same answer. Yeah, it's very confusing. For now. But we're still going to go in completing of the square of quadratics when we're busy with equations. What we have done was completing of the square of expressions. So you are a lesson or a couple of lessons ahead of us. Alright. Any other problems with 2.8? No. So, next heading. Solving quadratic equations with fractions by factorization. That's a mouthful. And that's on page 34. Okay, take that sum down. Okay. So firstly we should note is that division by 0 is undefined. Not so. If we divide by anything divided by 0 is undefined. So no denominator must be equal to 0 here. Not so? So if we look at the first fraction here, it's going to be x plus 1 over x plus 3. So x plus 3 can never be equal to 0. So x can never be equal to negative 3. Not so. We look at the second fraction. You got 2 over x plus 4. So what do we know from here? X plus 4 can never be equal to 0. And x can never be equal to negative. Not so? If you look here at the third fraction, you got 2 over x plus 4 into x plus 3. We know that the denominator can never be equal to 0. So x can never be equal to minus 4 and x can never be equal to minus 3, which is already represented. And this, people, the values for which x can never be equal to is called a restriction. It's the restriction on x. Okay? So what we do is, when we solve the sum, normally what we do first is, we write down the LCM. The first thing we do, before even writing down the LCM, we check if the denominator can factorize. So make a note there. First bullet, first important point in solving the quadratic equations with fractions. Fractions by factorization. So the first thing we do is, we check if the denominator, we factorize the denominators, if possible. We factorize the denominators if possible. Factorize the denominators if possible. Thereafter, we find an LCM. Then we do the restrictions, which comes from the LCM. I'll show you now how we do it. Then we multiply, then the fourth one is, then multiply each side of the equation then we multiply each side of the equation with the LCM. After we do that, it becomes a quadratic equation we are familiar with brackets and everything. Right? So you can put it then solve, whatever you want to say. Okay. So people, what's my LCM here? Lowest common multiple, LCD, what do you mean? X plus 3 is x plus 4. X plus 3, x plus 4. So if you look at this here, is x plus 4 accounted for? Yes. X plus 3 accounted for? Yes. So that's my LCM. What do you notice about the denominators? We didn't have to factorize. Okay, so the first point wasn't applicable. So what's the next thing we need to look at? Restriction. So what's my restriction? X can never be equal to negative 3. It's going to come straight from here. X can never be equal to negative 3. And x can never be equal to negative. You always write the LCM on the side and the restriction on the side. Okay. Now moving to first. So now we're going to multiply each side by the LCM. Right. So we ask ourselves, okay, the first fraction is shorting what in the denominator to get the LCM completely? X plus 4. So x plus 3 must be multiplied by x plus 4 and x plus 1 must be multiplied by x plus 4. You all agree with that? The sum is fairly small there. So I'm not going to it's fairly small. So I'm not going to show the multiplication next to the bracket. fraction. Okay, is that okay? So just this one here is shorting x plus 4. So I got x plus 1 multiplied by x plus 1. Not so. The second fraction is shorting what in the denominator to get the LCM? X plus 3. So if you multiply x plus 4 by x plus 3, 2 must also be multiplied by x plus 3.
Sir,
yes?
so I multiplied by x plus 1
So it's supposed to be x plus 4, no?
Yeah.
My mistake? Should be a 4. So what must x plus 4 be multiplied by? X plus 3. So it's 2 into x plus 3. And the last fraction must be multiplied by what? Not nothing. What? If you multiply by nothing, you're going to get it undefined. Not oh, it's a 0 you're talking about. Huh? Remember, multiplied by 1. So it will be plus 2 times 1. So you see now we got something we are very familiar with. Not so? So do you think quickly? So the pause. Alright, so at this point we are finished. You guys are finished. You multiply this out, get rid of the brackets. So x times x, x squared, x times 4 is 4x, plus 1x is 5x, plus 4 equals 2x plus 6 plus 2. Now what do we do? This is now a quadratic equation. Not so? So what do we do here? X is one side. All numbers one side, 0 the other side. Otherwise, if it was linear equation, x is one side, numbers the other side. So bring everything over, so it becomes x squared, 5x minus 2x is 3x. 4 minus 6, what's 4 minus 6? Minus 2. Minus 2 minus 2? Minus 1. Or if you want to write it out, no problem, and then add and subtract like terms, no problem. So what is this now? It was again a trinomial that needs to be factorized. So what factors goes on the line? Factors of 1 is 1 and 1. For 4, 1 and 4, 2 and 2. We add or subtract the factors. We subtract them because of the 4 is negative. 1 times 4 is 4, 1 times 1 is 1. 4 minus 1 is 3. So I got the 1 and a 1, so it's x and a 1, x and a 2. Is minus, so 1 plus 1 minus, the bigger one must be 4. The bigger one must be plus, because of the middle term is plus. So what do we notice now? X is equal to 1 or x is equal to minus 1. But now coming back to the restriction, which values can x never be equal to? Negative 3 and negative 1. But looking at the solution, what do you notice?
Kenyan house goes to meet in the prefect now first
That one
break.
is? No.
Kenyan house
So
to
it can
meet
be
in the
x is equal to
prefect now first break.
Okay.
Grey house to meet in the hall. And all tennis girls to please report to room 19 now at first break. All tennis girls to please report to room 19 now at first break. Thank you.
Okay, so listen. For homework, I want you guys to do you're going to do for me exercise 2.9. In 2.9, you're going to do number 1, 2, 3. In number 4, looking at number 4, you see that second fraction there? That fraction must first be swapped around, the denominator. Then a negative comes out. So you're going to do for me numbers 1 to 4 for tomorrow. Okay. People enjoy the rest of your day. Good morning, class.